continuation, we are talking about chi-square test in the research methodology. So this is a statistical method to determine the observed the categorical data that significantly differs from the expected one. So between your two variables. So significantly differ from your variable. Just you compare with the hypothesis, the null hypothesis. Already discussed in the previous chapter. So instead of representing the percentage, so here the data will be represented in the form of frequencies. Rather than the percentage, we are represented as a frequency. So this is the formula for chi-square test. So which is exponential of the value y minus ei by ei whole square. So the y stands for observed value. So the observed data, and the ei is vary from your expected data. So you know that we are going to relate with the hypothesis we discussed. Okay, so null hypothesis. So your observed value is different from your expected value. Where we are mainly using this in the social science research, market research, healthcare research. So as I said earlier, an example. So government expected, so in order to regularize the ration card in the specific region. So previous census conducted 2021, so they mentioned that almost 2000 people are living near the Pateri region. So then our SRM students are, for example, they are allotted to conduct a survey. So the students are separated in the groups and they visited the place near the Pateri. So the database is expected is 2000 families, but after the students having conducted the field visit, they found 1000 families are having a single child, and 500 families are having 2 child, and another 500 having 3 child. And some people are without children also, and some people are missed in the data. But overall, the expected value is not meeting the real value. So this kind of field work and also the marketing research, this chi-square test will help you. Okay. Next, maybe you can remember the chi-square distribution. So this is the important statistical software used to find the difference between your observed and expected value. So I already discussed about the formula. So the formula to calculate the chi-square value, the statistical value is your expected, that is observed value, and your expected value here. Chi-square is equal to summation of O minus E by O square by E. So where O is the observed value and E is the expected value. So you can to test the goodness of the fit. So the formula I discussed earlier. So if the value chi-square, this is lesser than your expected value, so the fit is not good. So it is also greater, so maybe you can get that fit is very good. So null hypothesis, already you know that null hypothesis, the fit is not good, and the null hypothesis, the fit is good. So based on the hypothesis you framed this, you are going to draw the interference. So some problems are there, maybe you can work, already we discussed. So goodness of fit, the validation of model. So an official from Tamil Nadu population census was conducted in 2021 and is reported that in Pateri town 60% of families have only one child and 28% having 2 child and 12 having 3 or more children. So to verify this, a student from SRM had decided to conduct this survey and found that 1290 families in the town and 730 had 1 children and 380 had 2 children. So whether this data supporting the results of the census or not. So the significant level alpha is equal to 0.05. Maybe you can assume it. And how you can solve this problem? maybe based on the survey you conduct, stating that null and alternative hypothesis, whether the data match well or not match well. So that's not, in the student survey, the data does not match the census. Either you get two results. One is your data supports the census result, or alternative hypothesis, in the survey data does not match with the census. So you will conclude your observation from the expected value. So this is null hypothesis and this is alternative hypothesis. So whether already we discussed, your salary is 10,000, you are meeting the requirement, you are spending money 8,000, means it's okay. If it is greater, you are earning 10,000, you are spending 15,000. So here it will not work. Okay, this is a chi-square test. So another one more example, maybe you can use this problem also. The chi-square goodness of it is approximate because we are examining the distribution of the variable, single variable. Maybe you can see number of children. So observed is 730 and 2 380 and 3 children is 180. So the total number of people observed is 1290. You are taking this and you are substituting as per the census and you got some value. As per the census, they give 774. As per the census, instead of 380, 361. Here 180 instead of 155. So you subtract observed minus expected value. You get some difference, maybe plus or minus. So observed your data is 730 and the census data is 774. So what you found? Some deviation. Some values are differed. And here also 2 children, you can see the census value is 361. But you are observed, you went to the field work, you got 380. Here 180, but census is 150. And you got some data. So observed value as well as expected value. Expected is here census value. So you got some data. And you are making square and you are substituting in the formula. From that overall summation, you get the observed chi-square value for this field work is 7.5. Right? You made a field work. So here variable you are taking as a children count and the number of people. So the census values differ. You substitute the formula and you get the chi-square value. So whether it's the expectation meets or expectation is lesser or the expectation is higher, we are going to form from this chi-square value. You can see some other examples also. Yeah, and the chi-square test also used to testing association between two attributes. So you can see this test for association determined between two or more categorical values. Two or more categorical values means any idea? Two or more categorical values. Adi you did expected and observed. So what is this condition? So expected and actual value. Is there any link between this your observed value that you are going to form? So between two attributes. So as a result, you are going to test the ideal choice for two categorical variables. I will tell you in detail. So just remember, this is an example for testing association between two attributes. Right? You can see this is the example. You are taking two attributes. One is smokers and non-smokers. So two attributes. Attributes means here two conditions. One is smoker and non-smoker. Topper student, poor student. Regular attending class, non-regular attending class. So take the overall value, performance, CGPA, everything will vary. Similarly, the smokers and non-smokers. Lung ailment with smokers is 450, without any problem is 70. Some students don't attend the class, but they are performing well. Some students attending regular classes and still they are getting 6 marks, 7 marks in the test. this is the kind of thing you can consider. Maybe smokers, definitely they have a health issue, lung ailment 450 and no lung ailment is 70 for the among them. And non-smoker 60 and no lung ailment is 420. So the total. So you are going to find a test between the relations between the smoking and lung ailment. This is a kind of relative. Maybe smokers also there, they have lung ailment or not lung ailment. Non-smokers also having lung ailment. The reason is pollution and they are traveling with their friends, they are having a smoking habit like that. So we can use this test also. So we can go for this formula. Here, framing hypothesis. So there is no association between smoking and lung cancer. And there is an association between the smoking and lung cancer. So here you can take two hypotheses. You are taking two hypotheses. There are hypothesis between smoking and lung cancer. Definitely smoking will cause us a cancer. And there is no association, there is an association between smoking and lung cancer. No relation as well as interrelation. Two probabilities. No relationship as well as a relationship. So constructing a table of expected frequencies. So you have to make a table with this match with the expected. So you can make a observed, smokers, non-smoker, lung ailment, non-lung ailment, total like that. So now you can go for this formula. So you can go with the formula and you will find the value. Size square test, expected and observed. Here in this kind of problem also your size square test will be helpful. So you can go for the size square formula, and the formula used to calculate this size square is observed, summation of observed minus expected by the expected. So you can substitute the formula and you can get the size square value test. So here you are going to fix the hypothesis. Possibility or not possible. Right? So this is the chi-square test used in the statistical formula in the research methodology. Okay? The F test. Next chapter is F test. This is a kind of ANOVA. What do you mean by ANOVA? Analysis of variance. This is a kind of ANOVA test. So what is the exact definition for this F test is, you are going to compare the variance of two populations. Compare the variance of two populations. For example, you discover a new drug. That drug is effective for some people. That drug is not effective for some people. So you are considering the population means two populations. Maybe you can take as a male or female. So kind of things you are taking, compare the variance of two populations, or you are going to determine the means of multiple groups are significantly different. So you are simply, you can tell that this is a analysis of variance. So this is a formula we are going to calculate. The F is equal to F test. The formula is S1 square by S2 square. You have a large variance, so it is in the numerator, and S2 square stands for small variance, that is in the denominator. So this is a formula to calculate the F test. It is again classified into two types. One is two-tailed F test, another one is one-tailed F test. Two-tailed F test, another one is one-tailed F test. Two-tailed F test means your two variables are two variants are unequal. So you are both, if you are having same value, instead of you are getting unequal value. So, and one-tailed F test stands for one variable is higher than the other. So this is called the F test. So we call it as an analysis of variance between your two populations. So this is called a F test. So again we come to the PowerPoint. So this is used in the hypothesis testing to check whether the variance of two populations or two samples are equal or not. That is the term. Okay. So do you understand or not? please keep quiet. So the F distribution under the null hypothesis is to calculate the variance as I said. So they here, if it is null hypothesis which is equal or which is not equal. So the criteria is if statistic is not equal to F critical value, then null hypothesis if rejected. So this is a condition. So you can go for a formula. There is some problem, maybe you can work with that. The research team want to study the effects of new drug in insomnia. What do you mean by insomnia? Sleeping disorder, sleepless disorder. So 8 tests were conducted with the variance of 600 initially. After 7 months, 6 tests were conducted with the variance of 400. As a significant level of 0.05. So is there any improvement after 7 months? The given F critical value is 4.80. So we have to compare with the null hypothesis and alternative hypothesis. Whether S1 square is equal to or whether Sn square is not equal to S2. So this is initially conducted, this is after 7 months they conducted. And here number of tests 8. So the DF is equal to 8 minus 1, 7 and S1 square is equal to number of people who are checked is 600. And next 7 months they conduct 6 and DF2 is equal to 6 minus 1 because n minus 1 probability. But you know the math, right? So, and 5, so S square is equal to 400. So we are going to substitute in the formula, F test formula, S1 square by S2 square for small sample. So 600 by 400 you get 1.5. As 1.5 is lesser than 4.88. So here the value is given as 4.88. But here you observe that the value is 1.8. This is lesser than your 4. So the null hypothesis cannot be rejected and there is not enough evidence to conduct the improvement of insomnia after using the new drug. So after, even though you are testing, the value does not meet the null hypothesis. Here you can see this value. So this new drug is not effective in the people. So this kind of test is conducted for the new drug discovery. So another one example, maybe you can work. I will share the material. You please check with that. Okay. So this is